So let's look at HF. Let's start with the difference in electronegativity. You do your calculation and you find that the difference in electronegativity is equal to 1,9. Now you have to know those values. Do you agree that 1,9 is between 0,9 and 2,1? Okay? Met ander woorde, hierdie verbinding kan ons klassifiseer as 'n polare binding. You can classify this as a polar bond. So we can go and we can check the first box. Now we need to go back to the symmetry of this molecule. Now remember I told you guys, linear does not equal symmetrical. So the way that I like to think about it is, does this thing have two different sides? Sien julle uit 'n kant waar die swart balletjie lê en 'n kant waar die pers balletjie lê, né? Terwyl as ek hierdie ene gaan optel, uit 'n kant waar die groen balletjie is en 'n kant waar die groen balletjie is, die twee kante is dieselfde. That's a good way to explain to yourself, is it symmetrical or is it not? Does the two sides of this thing differ? Nee, sien julle? Albei sy kante lyk presies dieselfde. Does this one have two different sides? Yes. So this is an asymmetrical molecule. Want as ek hom hier af gaan sny, dan is dit nie 'n spieelbeeld van mekaar nie. So in other words, it is still linear. The shape is linear, but this is an asymmetrical linear molecule. Jy hoef nie te worry nie, die ander het nie 'n symmetries en 'n asymmetries nie. Okay. But linear, you guys understand that you can get a symmetrical linear and an asymmetrical linear. So, hy is asymmetries, so ons gaan check daai boksie. Met ander woorde, hy het polare bindings that I get from there. It's an asymmetrical shape. In other words, the molecule is polar. Now look what we do here. Sien julle waantoe wys die pyltjie? Die pyltjie wys na die F toe. The arrow points in the direction of the two which has the highest electronegativity. Now fluorine always has the highest electronegativity, so that will always have the arrow pointing towards it. But if it's not fluorine, how will you know? Hoe sal jy weet na watse kant wys jou pyltjie? Jy kyk net op jou periodieke tabel, né? So op jou periodieke tabel sê jy sien fluor is 4 en waterstof is 2,1. So stem julle saam, fluor is hoër. So this arrow indicates the tendency of the movement of the electrons. In other words, the electrons will tend to spend more time on the fluorine atom. So they will move slightly towards there, and therefore you get a slight negative charge on the fluorine, and you are left with a slight positive charge on the hydrogen. So it will have a positive side and a negative side. Okay, presies dieselfde is op toepassing op HCl. So ons kan gou vinnig deur hom hardloop. HCl, do you agree the shape is linear but it's not symmetrical? Okay? Then we do the sommetjie and we say it's 0,9. That is on the edge. It's a polar bond. In other words, polar bond, asymmetrical, polar molecule. So what do you do then? You see that Cl has a higher affinity for the electron. So the electrons tend to spend more time on the chlorine than it will on the hydrogen. So it becomes slightly negatively charged there and slightly positively charged there.
We don't have to know that.
You do? Why are we doing this?
No, I mean, I'm looking at the next two and I don't.
We're going to do them now. Okay, goed. Dan water is altyd 'n gunsteling om te vra. The reason why it is angular, you have to know, comes from the Lewis structure. So because we fill our orbitals 1, 2, 3, 4, 5, 6, né? Dis mos hoe ons orbitale gaan vul. You are left with one hydrogen at the bottom and one on the side. Or it doesn't matter where, but they will be next to one another. They won't be opposite one another. So it won't be a linear molecule with 3 next to one another. It will be angular. Okay. Water is 'n baie groot gunsteling vir hulle om hier te vra. So use that as your reference point. Okay. So because we fill our orbitals 1, 2, and then 1, 1, 1, and then the second electron there, we have 2 lone pairs next to one another, and we have 2 hydrogen molecules next to one another, and then it forms this. Wat julle al 100 keer gesien het. Stem julle saam, hy het 'n hoekie. Hy's nie in 'n reguit lyn nie. It has an angle. It's not in a straight line, and that is where the name angular comes from. Okay. Now, do you agree that this one has a few axes that it is symmetrical on? For instance, if I cut it in the middle, it is symmetrical. But it is not symmetrical on all its axes. So always use the bonds to test if it's symmetrical. If I use this bond, do you see if I use this as a mirror, it's not symmetrical. Stem julle saam? Dan het hy een aan die een kant, maar niks aan die ander kant nie. Okay? So kyk op die bindings. Dis die maklikste manier om te sien of hulle simmetries is. So do you agree this is an asymmetrical molecule? Hi Bertus. Okay. Hy is 'n asymmetriese molekule, so we check that box. Right? Asymmetrical shape, checked. What is the name of this shape? Angular. Why is it angular? Because it has, what do we call these? Lone pairs or single pairs. Okay, alleenpare. Got it? What do we do next? We check the first box. What do we do next? Ons gaan werk die polariteit van die bindings uit. How do we do that? Hierdie minus sommetjie. So ons lees af 5,3 minus 2,1 is 1,4. So I have twee polare bindings. Don't tell me it's 2,8. Don't say because we have two different ones, you time this by 2. Each one of your bonds has a difference in electronegativity of 1,4. So both of these bonds are polar. You can't add them together and get to 2,8 and then say it's an ionic bond. You have to say this bond is polar covalent and this bond is polar covalent. Okay, met ander woorde, in hierdie verbinding, waar gaan die elektrone meer tyd spandeer? Op die suurstof of op die waterstof? Op die suurstof. On this bond, where will the electrons be spending more time? E. No. So if we look at it like this, which side will be slightly positive? The top side. En dit is waar daai pyltjie vandaan kom, Lydia. Do you see it's pointing upwards? Because the electrons spend more time on the oxygen. Okay, so watse kant van hierdie molekule gaan positief wees? Die bokant of die onderkant soos ek hom nou hou? Watter kant gaan positief wees? Die onderkant, né? Want die elektrone is weggetrek van die waterstof af. Do you guys see this? Okay. And will it be a polar molecule? Ja, hoekom? Want ons het al twee die boksies gecheck. Ons het gesê dis 'n nie-simmetriese struktuur en die binding self is polar. Okay. Ek dink ons gaan nog net twee kan doen, maar dit maak nie saak nie. Now I'm going on to this one. If you draw the Lewis structure for NH3, it's always worth drawing the Lewis structure. It looks like that. Do you agree? Immediately you see that it has a lone pair. Okay? Wat beteken hy 3 bindingspare, 3 bonding pairs, and 1 lone pair, which you have to know means that it will form a trigonal pyramidal shape. Okay, ek gaan nou vir julle afkondigings lees. Wat beteken hy is asymmetries? And then you go do your calculation. It has polar bonds. So because it is asymmetrical and it has polar bonds, it means that the molecule will be polar. Okay, voordat ek vir julle lees, wil ek net gou vinnig hierdie twee 'n soort gelyk. Okay? Maar ek gaan nie nou te veel worry oor die CS2 nie, want op hom kry jy in elk geval die elektronegativiteit van 0. So it has an electronegativity of 0. In other words, it has non-polar bonds. So it can't be a polar molecule. But for carbon dioxide, if you draw the Lewis structure, you'll see that this is a linear structure. Nee, so hy lyk mos so. Okay. And this is one of the cases where we can only tick one of the boxes. So as jy gaan kyk, as ons hierdie sommetjie gaan doen van 3,5 minus 2,5, stem julle saam, die binding tussen die koolstof en die suurstof is polar. The bond between the carbon and one of the oxygens is a polar bond. But because this is a symmetrical linear molecule, you can't tick that box and therefore it is a non-polar molecule. The bonds are polar, but the molecule seen as a whole is non-polar. Okay. Goed. Graad 11's. Julle gaan moet deur daai laaste 3 gaan kyk Kyk maar net laat jy die jou boksies check. En dan wil ek hê julle moet vir my, daar's ons vir julle lekker opsommingkie, dit help baie. I want you to go read through page 7, but you already studied that. En dan wil ek hê julle moet vir my gaan kyk, dit is op die video, na die faktore wat die sterkte van kovalente bindings bepaal. That's theory. Go and read through it, make sure you understand it, it's not very difficult. And then you'll see on the video that I'm going to post for you guys, she goes through these calculations as well. Okay, so try to follow through those calculations. En dan hoef julle nie hierdie goeders te doen nie. Maar dit word op die video ook gesê. We need to carry on with